Hello, we have more of our favorites today. Pre-Calc Lesson 17, Proof of Pythagorean Theorem, and Proofs of Similarities, all about the proofs. So, the Pythag theorem. Okay, I'm going to prove it using similar triangles. I have this big right triangle. I'm going to call this M and this K. And I have this triangle here on the left. If I call this A, B, here I have angle X. I'm going to say this is Y. And this whole length I'm going to say is C. Okay. So, I'm first going to draw, okay, this is figure 1. Figure 2, I'm going to redraw one of my triangles. M, A, and this is X, right? X is this segment here. Y is this segment here. Okay, and I can say that these are equal. And my third figure, I'm going to say I have B, Y, and K. All right, I apologize. Okay, now if I look at my big triangle here, I know that this left angle is similar with this angle here, right? Which proves to me that these are two similar triangles. I'm going to call this J. So I have a J here, let's call this F. So I know that triangle MJK is similar to triangle MJF. Okay? Which, if that's true, then between triangles 1 and 2, I can set up the ratio C over A equals A over X. Now let's look at triangle MJK and this triangle here, which is triangle JKF. I can actually say that they are similar triangles also because they share this angle here. And since that is true, I can set up these ratios. Okay, so now let's cross multiply in each of these. So I get CX equals A squared and CY equals B squared. Now what if I added these together? So I get CX plus CY equals A squared plus B squared. That's one of Euclid's postulates that we can do that. Okay, and I'm going to factor out a C from here. So I have C times X plus Y equals A squared plus B squared. And if I look up here, I know that C equals X plus Y. So this really is C times C equals A squared plus B squared. C squared is A squared plus B squared. Woohoo! Now we at least have a reason for why we can use Pythagorean theorem. Okay, now there's another proof in your book. It uses area. It's a fun proof as well, but I'm going to move on for the sake of your time. Okay, and let's talk about proofs of similarity. Okay. Now, similar triangles. Okay, we know in similar triangles that the measures of three angles in one triangle equals the measure of all three angles in the other. Okay, now our notation is we say that angle, angle implies angle, 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 right? If I had this triangle and this triangle, and I said those two angles were similar, and those two angles were similar, okay, I can therefore say those two angles are similar because angle, angle implies angle, angle, angle. Okay? Now, just to recap, congruent triangles, we can prove they're congruent by side, 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 angle, side, angle, 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 side, or hypotenuse leg. Okay? We have to remember these. So let's do some proofs. Everyone's favorite. Okay, if I have this figure, and I say this is B, A, C, D, E, and I tell you this and this, I want to prove that triangle ABC is similar to triangle EDC. So I have my statement and my reasons. Okay, my first statement is that angle A is congruent to angle E, given. Then I'm going to say angle BCA is congruent to angle DCE. We've done this a lot, so we should be pros. And I say vertical angles. Then I say angle B is congruent to angle D because angle, angle implies angle, angle, angle. So therefore I say triangle ABC is similar to triangle EDC by angle, 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 saying that if all three angles are equal, therefore they are congruent. Okay? We should be pros at this. This should all be review. Let's do another example. Okay, prove triangle ABC is similar to triangle DEC. If I have this figure, A, B, C, D, E, and I have that going on. Okay, so statement, reason. Okay, first I say that AB is parallel to CD. That's given. Okay, now I want to go with the easy. I want to see that angle BCA is congruent to angle DCE, vertical angles. So I know that this is true. Then I can say angle A is congruent to angle D. Okay, because they are, if I look in here, alternate interior angles. We cannot forget about alternate interior angles. Then we say angle B is congruent to angle E because angle, angle implies angle, angle, angle. Therefore, triangle ABC is similar to triangle DEC by angle, angle, angle. Okay, you should be very familiar with all of these different ways to prove two triangles are similar or congruent. Let's do another example. We want to prove that triangle GHI is similar to triangle JKL. Here are my triangles. Okay, little different. We're actually going to use a different reasoning even. Okay, I first say that angle G is congruent to angle J. That's given. Both are 30. Okay, then I can say that GH over JK equals 12 over 8. That is given. And then I can say that GI over JL is 15 over 10, given, which if you have figured that out, you can say that GH over JK equals GI over JL because 12 over 8 equals 3 over 2, which is the same as 15 over 10. Now, here comes the kicker. we can say triangle GHI is similar to triangle JKL by side, angle, side. Okay, we can actually use side, 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 and angle, angle, angle for similar triangles. Now, in this case, the sides are proportional, not congruent. That's the big difference, okay? We're talking about proportional sides, not congruent sides, okay? And as always, if you have questions, bring it to class tomorrow, but that is all for this lesson.